Good afternoon, welcome to the third session of today. It is really a real pleasure to introduce my good friend Paulo Novais. He's a well-recognized researcher in the area from Portugal, was president of APIA, Portuguese Association of Artificial Intelligence, responsibility playing in Portugal, and responsible of the research in artificial intelligence in Minho University, and he's an expert in a lot of areas, has really an excellent curriculum, number of papers, and I suggest you to read his book about small LLMs. Is the first book was written in the topics, very important because really is the future from the point of view of the sustainability and according to the cost of a big system, as we discussed this morning with Julia, and really it will be a pleasure that Paulo will introduce us Agentic in Action, and Pedro also will have the second part of the session from a more practical point of view. Correct, Pedro? Okay, thank you very much. Paulo.
Muchas gracias, señor Herrera.
No, esto lo quito.
Forgive me, too much technology. Okay. Your human touch is still important, and we forgot that. Many thanks to the invitation. It's a pleasure, and probably more than that, an honor to be here. And I expect to be at the level that you expect from me. I'm not sure. Okay, I will try to divide this presentation in two parts, if you don't mind. I will do the first one, in which I will present the more theoretical aspect or dimension of our work, and in the last part, I will ask to Pedro, that is co-author with me and with João of a lot of this work that represent the last 3-4 years our life, okay, at least. For me, I will try to present not at the level of the framework, the agentic AI, because most of the previous speakers have done that better than me, and will do better than me. For sure, because they are the ones, in some case, that are building the frameworks. I'm more at the level, the ones that try to use this framework, and it tends to create new architectural frameworks, in the sense that we want to integrate different approach, multi-agent system, firstly, because the foundation of agentic AI comes from the traditional models in multi-agent. We are using also the reinforced learning, of course, and you will see in the way in the system that we think it is appropriate. And of course, we cannot be. We should use in our days what are so important, the LLMs, at the level of the previous speaker present very well. I don't know if you look well, he present a kind of perspective model, the ones that take in account the perception, and most of our system have these three dimensions: perspective, the reasoning, and generative in our days, okay? But because some years ago, I was with Paco and Professor Francisco Herrera, forgive me, in different conferences, and we present that like perception, reasoning, and action. In our days, we talk about perspective, reasoning, and generative models to do the action, or to give the plans to do the effective action. But I want to put in context this moment of AI, because I believe that we need to understand that AI means grasping the shift from automation to autonomy. AI, in my humble opinion, is not merely a matter of algorithms. It represents, in a certain way, a new grammar of economic and social power, because with this new AI, we can do the difference, namely creating systems that will transform completely, that's my expectation, our society. We are, in a certain way, moving from machine that execute to machine that, or system, if you prefer, that decide, which require us to have a blown vision of this. The AI is now today a mosaic of different capability, ranging from tools that automate routines to tasks, to systems that mimic human reasoning in a certain way also. Okay? We can observe that with what I call the 3 waves of AI. The first one was the rule-based engines, and we are going from that to autonomous agents. And the evolution of AI can be understood to these 3 distinct overlapping waves, okay? And each of them represent a fundamental shift in how machine, how system process information, learn, and act, okay? I remember to you the first wave, the one that when I was in your place, I started to learn about AI, was really relying on handcraft logic, if you want, the system that follow explicit rules defined by a human expert. And operating with full transparency but limited flexibility, that is so important. The second wave replaced the rules with data, as you know, enable machine to learn from statistical pattern at scale, okay, and looking remarkable capability in language, vision, prediction at the cost of, but with the cost of the, reduce the cost of interpretability. The third wave, the one that we are living in at the moment, still emerging, but introduce the new paradigm of agency, and we are developing systems that plan, act, collaborate, and act autonomously over extended time frames. Together, for me, these 3 waves trace a progression from tools that respond to systems that learn and to agents that act. We can so also synthesize and look from different dimensions of AI and see the evolution in terms of the different reasoning into autonomy in the 3 waves. And this is very interesting because, at least for me, AI is transforming what I mentioned before from a tool that we can use to agent, and in certain way they are also, for example, if you observe AI from the point of view of law, they don't now call our system tools, they call it artifact. Why? Because artifact for them means they have they add 2 different dimensions to the tools. One is autonomy, but we should remember that we have always some kind of autonomy in the first wave. But if we add learning, the capacity to learn, this artifact becomes no deterministic. And that's why they don't call it tools, simple tools. Okay? Of course, there are some dimensions I don't put in this frame. Imagine we can also observe this from the point of view energy consumption, the safety and alignment with the, I forgot to, okay. The alignment with the human's value, the privacy and data dependence. For example, the previous speaker, in a certain moment, I don't know if you note, but he put a system that can understand the signal and understand what we are doing. I think he mentioned one user was using a Zoom system, imagine, and the other one was only download, okay, of things. Okay, that's perfect, that's very good, but it is in the border between, you know, and privacy. Sometimes I know that we can do everything, but there are, as I mentioned to Kelvin a few moments ago, there are something that we can do, but we should not do. You know, that's difficult to separate and to do the right things, by the way, okay? Yesterday, by the way, the speaker, when we was in Alhambra, said Alhambra means right. We understand right, but it was mean red, by the way, our speaker. It's quite interesting. So, and by the way, also the different, there is a dimension that is not here, is also the dimension related to the implementation cost. But the interesting things, and just to finish this approach, it's to see how it shifts significantly from waves to waves. Okay, okay. That's my just a few moments to put the things in context that I believe it's important and to not forget. Okay, my talk will start in two different 6 main parts. First of all, we will discuss the motivation and explain why agentic AI is needed at this moment. But most of my colleagues, previous colleagues, have done that probably better than me. We will also revisit the fundamental components or foundational components, multi-agent system, reinforced learning, and large language model. And after that, we will explore in more details an architectural design of agentic AI system that include orchestration and some certain memory mechanism. And we will then analyze interpretability, learning aspects that I believe are quite important in this kind of system. And we will just present a real-world environment monitoring case study that we do in our lab. Yeah, and represent most of the work of Pedro, by the way, in his PhD. Traditionally, AI systems were largely reactive. It comes from the first wave of the evolution of AI. They respond to input, but do not maintain persistent objective or long-term strategy, as you know. Whenever modern environments are dynamic, uncertain, and distributed. So we need to change, in a certain moment, we need to change that and evaluate our system to be prepared to this dynamic uncertainty and distribute dimension of the environment in which we are creating this system. So this creates the need for systems that are capable of prolonged autonomy, continuous learning, and multi-agent coordination, if you want coordinate. Because most of because in a certain way, I think I forgot to mention that, in the 3 waves of AI, if you think well, in the first 2 waves, we are solving the problem to do or to perform a certain task. And in the third one, we are going far from this. We are now trying to implement works. Works in this context for me means a set of different tasks. If you want a complex task, a work, and for that we need tools to implement the simple task that compose the work, okay? And the third wave gives us this possibility, and that's why a lot of different works now are full autonomous, or if you want, with minimal intervention of human in the loop. Imagine the supply chain mechanism, for example. Most of them are work done by humans, by the way. But if you look well and do a division, you will see they are composed of several different simple tasks that can be done by a system autonomously. Okay, so in my humble opinion, agentic AI emerged as a response to this demand. We don't aiming to create systems that not only predict, but also deliberate and act. Okay? Okay, agent AI refer to systems that demonstrate contextual perception, and the previous speaker was fantastic. He presented us the predictive model very well. But we need also intentional deliberation, and we need adaptive learning, because in most of our works, in fact, we are continuously trying to learn to achieve this work better, okay? And I believe the system that should have also this mechanism that it just not perform, it look at the result and try to adapt and to be better in the next time, or eventually when we do a mimic of human. Typically, before to do act, we are simulating the task we are doing, and we are, in fact, trying to adapt to be better and to perform better the task. Okay, that's more or less our goal in this system. Forgive me.
Let me a question, please. 2 days ago, Bastian from Zurich, in his presentation, he presented that the agent AI has no intention. I was discussing with... the intentional deliberation.
Okay.
In the
they
presentation...
have no intention.
They have no intention, but in any way, it simulates it has not human intention, but it has intentional deliberation, and in some way, it is a simulation of the way to take the intention, the human, that's similar to deliberation. Then the problem is when we compare the exact term from human to the machine.
Of course.
And then, for me, it's very important your point, intentional deliberation, because there is this kind of agents. They have goals usually because you propose them action according to some goals. They are autonomous in order to get the goals, and then there is a deliberation and intentional deliberation. Then I like a lot of this is intentional deliberation, no human intention, but it's very important because they are different, but this is a way to consider the intelligence. In my opinion, is another kind of intelligence, but we cannot compare continuously both kind of intelligence. But we can use intentional because there is an intention to take the decision.
I agree with you. One of the big mistake in our field is trying to always look at the machine in the same way that we look to us and to how we work. Of course, we believe we are the more intelligent agents in the world, in that sense, and of course we should look at human as a kind of example of and inspiration, but we will pay the price of compare too much with AI, and eventually even to develop systems that are like humans. We will pay a price in the future to do that. Okay, it's better the vision of, imagine Jan LeCun, that say AI is a kind of augment intelligence to help us. In my vision, we should look at the system as a kind of lens, a cognitive lens, no? With a lot of systems that are a kind of lens of cognitive that help us to look at a world that become too complex. Too complex means there are too much dimension that we need to take in account to act, and we need someone that reduce the dimension, the number of dimension, to put it in the space in which human can decide. You know, for me, AI is it. Understand? Okay. Normally, I use an example. My grandfather was a farmer, and he made wine, grapes. He don't do wine, and to determine the price of the grapes, it was only the level of production of the valley in which we live. By the way, I live in Portugal, in Guimarães, in a valley called Centre, very small. But in nowadays, my uncles, that the part is not true because my uncles, we don't stay with the lands, but okay. But imagine that I have uncles that produce grapes. To determine the price, should take into account the price in Chile, in Spain, in other continents or countries. And the process becomes too complex for them, okay? That's why I think AI can help us to reduce and put the decision at a human level, okay? But because we have limits. As all the machines, we have cognitive limits. Sometimes we forgot that. And most of the problems, by the way, I believe in that moment we live in our society is because of that. We have limits and we cannot, namely at the level of perception, we have too much perception, we receive too much information, and we are not able to consolidate the information. It's too much, okay? We have a kind of bug in our perception level, okay? So we need to reduce the complexity. Forgive me. Now I don't know where I was, but thank you, Professor, to help me in this context. Okay, so I have already mentioned that. So multi-agent system is just a recapitulation of it. Give us the consistent multi-autonomous agent operate with shared environment in which and each agent should have what we call a partial perception. That's normal. Even us, involved in the problems, we have partial perception. We don't need to know, or we don't have the capacity, the research to have a global perception. Okay. Even I imagine when I'm supervisor of someone in a PG, I made an overview of the problem. I am at that level, but the student and the others have probably have a partial knowledge about or perception of the system. That's normal. It depends on the level in which we are. Okay. So, but this system can exhibit cooperation or even competition and are inherently decentralized. Okay. So. The multi-agency provide the social dimension, in my opinion, of the agentic AI, enabling distributed decision-making and coordination in the complex settings. Reinforced learning enables agents to learn through interaction with the environment. That's the key factor and give us, namely to us humans, the ability to adapt and to rapidly change our actions. Imagine I was interrupted very well by Professor Francisco, and I should stop, but I adapt because I was not expecting his comment. Okay, so an agent in that context perform action, receive rewards, okay, everyone know, and update the decision policy to maximize long-term performance. In agentic AI, reinforced learning provides the adaptive component that allows system to refine strategy over time. A large language model, everyone knows, based on transformer architecture, introduced the powerful reasoning capability in natural language. That's very important. That they can plan tasks, generate explanation, translate goals, and coordinate agent through semantic communication. Typically, in the previous state of multi-agent, it was not semantic communication; it was syntax communication. That's really different. So, for me, in this context, I see LLM acting as a kind of cognitive interface that enables interoperability and high-level planning across agents. You know. That's in a place in which I believe LLMs and the different LLMs we will have in the future should be at the cognitive interface. Agentic AI emerged from the component of, in my humble opinion, of these three different dimensions. Mass, as I say, contribute to the social coordination. Reinforced learning enable It enables continuous adaptation, okay? And the LLM provides the semantic reasoning and explanation that is so important. Together, these three components create a deliberative system that capable of maintaining persistent objectives and prolonged autonomy. The architecture ensures that learning, coordination, communication are integrated rather than isolated. Okay? So, an agent is an entity capable of perceiving its environment, make decisions, execute action, and pursue its own objective. And this property from the foundational building blocks of what I call an agentic AI. Okay, the multi-agent system operates with a share. So we have an agent, now we create a community using the multi-agent system that operates with a shared environment characterized by partial perception, as I talked about that in previous moments, and continuous feedback. That's very important. Each agent do not have a full knowledge of the global state and action taken by one agent, and an agent can also influence the others. But this introduces a certain level of uncertainty, incomplete information, and content and constant change in the environment. So, with this, the environment becomes dynamic, no static, and require, obviously, adaptive strategy. Managing this complexity is one of the central challenge of the agentic AI architecture aim to address. Okay? Agent multi-agent system, and now I believe we can talk about what we call emergence. Emergence in that context refer to collective behaviors that are not explicitly programmed, okay, by us and by the architecture of the system, but arise from interaction among agents. Through cooperation, competition, or even negotiation, agent can generate spontaneous coordination patterns, okay? And we see that in different simulations that we have. And creating even dynamic specialization or collective adaptation, okay? This phenomenon, if you want, is very powerful because it allows the system to self-organize. However, it's also introduces unpredictability, obviously, make governance and interoperability essential components of this kind of architecture, okay? So, as I referred before, coordination among agents may take the form of cooperation, competition, negotiation, or even simple information sharing. However, coordination also introduces challenge such conflict of objectives, of course, misalignment, and communication overload. Even the agent can have communication overload. Without proper mechanism, agent may pursue incompatible goals or even be inefficient strategy, okay? Agentic AI, therefore, include coordination protocols and should include coordination protocol and orchestration layers to maintain coherence and system-wide effectiveness, okay? So our system should have a level in which it make a kind of overview to maintain the system to do what it should do, okay? So, we introduce what we call multi-agent reinforced learning. In each agent learns simultaneously while interact with others. Okay? This creates, in my opinion, no stationary environment because as one agent updates its policy, the environment effectively changed for the others. Okay? Because he influenced the others. We don't live alone. We don't have agent isolate, okay? I expect to be in that moment influence you, okay? This leads to challenge in conversion, stability, and fairness among agents. So this kind of system require mechanism to balance exploration and exploitation, by the way, okay? While you know the difference between exploration and exploitation, okay? While ensure that learning remain coordinated, so our expectation, and we can control the learning and coordinate that, and do not destabilize the system, okay? Agent in multi-agent can develop their own communication protocols to improve coordination. There are a lot of papers that talk about that in the net. You should take into account this. But they may create internal signals or automate even symbolic exchange to maximum efficiency. Just remember when we play cards, okay? Some teams create signals to exchange information, okay? That's normal. We should not be afraid of that, okay? And even agent, because we give them autonomy, can create this. I don't see the problem. The problem is to maintain a level of coordination if you want control, okay? That's the main aspect of this. But while this can change performance, if often result in communication patterns that are difficult to humans to interpret, okay? That's obviously the only problem that we have. In the same example occur when we play cards. If you could understand the signals of the others, obviously we have something advantage in the game. But this limitation motivates in this case, natural language can provide the interoperable communication between agents and humans. It's enable what we call semantic coordination, tasks transform and collaborative decision making. Unlike abstract internal signal, natural language explanation can be understood by experts and the stakeholders. Okay? This allows the system to scale cognitively, meaning they can handle more complex tasks while remaining accessible and transparent to human supervisor. Okay? So, in agentic AI, language model function as a cognitive engine. They can act as a planner, coordinate, goal transfer as an explanation generators, and even interface between human and agent, okay? Rather than replacing other learning components. The LLM structure high-level reasoning and communication. They provide what I call it semantic consistency across agent and enable context to understanding that in change coordination. Agent and AI represent the integration of autonomy from multi-agent system, adaptive learning from reinforced learning, and reasoning and language capability from language model. This integration creates what we expect, a persistent system capable of maintaining dynamically objectives and reflexibility. We will talk about that later. This architecture is not merely adaptive, it is synergistic and ensure that the social interaction, learning and semantic reasoning can operate consistently. In my humble opinion, this means that you represent a paradigm shift. Instead of isolate models designed to fix tasks and reactive response, we are moving toward to cognitive system characterized by continuous process and deliberative decision making, okay? Intelligence is no longer confined to a single model, okay? But distribute across coordinating agents that learn, reasoning, and adapt over time. This shift redefines, in my opinion, how we conceptualize artificial intelligent system or intelligent systems, as it was normal also to denominate this. So, the current AI system often relies to isolate model, connect through ad hoc integration. This integration lack of clear structure and are difficult to scale and to frequently produce inconsistencies when systems grow more complex. So agentic AI proposes a modular and explicitly coordinated architecture that ensures that continuous information flow in a structural or structured interaction between components, okay? So this architecture is not only designed for performance, but also for coherence, scalability, and governance, okay? So agentic AI operates through a continuous cognitive cycle composed of understanding, interpretation, decision-making, action, learning, and objective adjustment, okay? This process is a never-ending, of course. Unlike statical models that produce output once deployed, agentic systems continuously adapt their internal representation and redefine strategy. This ongoing loop ensures adaptation to the environment, change, and sustainable align with long-term goals, okay? So modularity, in this case, is a key decision principle in agentic AI. Different agents or models specialize in sensing, analyze, strategy, or communication, more or less the same of the previous speaker talked about. This specialization alone easy replacement and upgrade and scalability. Instead of redesign the entire system, when improvements are needed, the individual model can evolve independently, okay? So modularity is also supported by what we call distributed computation and resilience in complex systems. The architecture is organized in 2 layers, okay? The first one is the sensory layer in which we collect data. In the previous speaker, he talked about the predictive reasoning or model. It's more or less the same for us. We collect the data, and then the next level take in account that data and process the information. Okay, it's different names for more or less the same things. Of course, in different complex systems. The previous one was more complex in the sense that he analyzed the signals. Okay. But not in all the system we need that. In some case, we don't need to analyze the signal. We have text, we have image, and we use that input, okay? So the cognitive layer process and interpret that information, as I mentioned. The strategic layer formulate decisions and plans. Is more or less the reasoning model of the other one. And the social layer coordinate agent and manage the communication, okay? So information flow both vertical across layers and horizontally between agents at the same level, okay? This layer structure ensure clarity of responsibility and coherence coordination. The scalability requires computational distribution, specialization of agent, efficient communication protocols, and resource management strategy, okay? As the system grows, complexity increases exponentially, that's normal, but agentic AI addresses this by organizing agent into structured cognitive system where responsibility are distributed and coordination mechanisms stable alongside computational capacity. So obviously we know that modern AI systems, especially the one based on deployment model and others, are often described as a black box due to their high complexity and massive number of parameters. Everyone of us know that. But with this model, achieve impressive performance. Also that. So their internal reasoning processes are difficult to interpret. This lack of transparency creates risk in critical domains such as healthcare, as you know, finance, environment management. So how to deal with that is a problem for us. So I believe in agentic AI, interpretability is not an option. Okay, it's a structural requirement and should be embedded in our architecture. Okay, so we know that there are different traditional methods to explain AI. Professor Francisco Herrera knows that better than me because typically talk about that in different talks. So I will not go in details because I will lose the race with him. I will lose always the race, but I can try sometimes, okay? So there are different models, but we know they still have limitation to technical, because sometimes they are more technical explanation, the previous one methods give us. It's difficult for no expert to understand that. We know that, okay? And sometimes they are not very accurate. They are more approximations, okay? So we need something more, okay? So I believe that we can use the LLM, can serve as a kind of explanation or explainable interface by translating internal system states into natural language explanation. That's the key goal of this. We want to use the LLM to help us to translate the technical dimension of the explanation in the natural language and to us, okay? It could be good. This produces what we call a contextualized decision, adapt explanation to different audience. We know the capacity that LLM can be used to present different narratives from different audience, and can reduce the bridge between what we call the gap between technical process and human understanding. This is not, by the way, eliminate complexity, but it provides what I call a semantic layer that make reasoning accessible and transparent for human supervision. But we need more. We need also the system goes to reflexivity, okay? That goes beyond simple learning. It's referred to a system that have the ability to monitor its own decision, evaluate the performance, detect inconsistencies, and adjust the behavior according to what I call a reflexive system that does not merely optimize reward, okay? It reflects on its internal state and align with the objective. This meta-cognitive capability represents, in my opinion, a significant advance on the development of agents systems. So reinforced learning focus on maximize the cumulative reward of time. It relies on the value function decision policy and the balance between exploration and exploitation. So the agent can continuously adapt his strategy based on the feedback from the environment. And the agentic AI and reinforced learning form the adaptive backbone, enabling the system to improve their performance through continuous coordination or interaction, sorry. Language models themselves are often aligned with reinforced learning with human feedback, okay? Commonly known as reinforced learning human feedback. This process fine-tunes the model behavior according to human preference and safety requirements. Means that in certain moment we have human feedback that reinforce the adaptability of the system. Because obviously we can, even autonomy have limits, okay? Imagine your kids, you give them autonomy to do things, but you are at a supervision level and you say, be careful. When he's near, imagine he is going with the bike and you can break something, okay? So this alignment is essential to ensure the consistency, the reliability, and the ethical compliance of the system. So in agentic AI, alignment mechanism, sorry, sometimes I have difficulty to pronounce a certain words, extend beyond LLMs and to entire system architecture. Okay, but despite its promise, agentic AI have faced technical and conceptual limitation. The technical challenges include the high computational cost. Sometimes we forgot that, but it's also important. The instability in the multi-agent learning system, and the scalability of constraint. Okay? So these conceptual changes involve governance, ethical alignment, and maintaining the control over the immersion behaviors. So ongoing research aims to address this limitation through to the architecture and evolution methodology. Okay? So agentic AI system is not static, as we see. I believe it is evolutionary. And the continuous adaptation means the system adjusts the system to the environmental change, update strategy, learn from mistakes is also important, and revise objective when necessary. Okay? Instead of maintaining a fixed behavior, it's involved alongside the environment. This property is essential in dynamic real-world context where conditions shift over time. Okay? But in my opinion, agentic AI is not designed to replace human, but to collaborate with them. Okay, it's enabled, in my opinion, what the level of supervision, for example, the strategic adjustment, and informed decision making. It means that humans remain responsible oversight for and evaluate the alignment. Okay, this architect should support an hybrid model in which humans and AI systems interact continuously, combining, obviously, limitation of the computational power with human judgment. Okay, so this figure provides a high-level representation of our cognitive system, illustrating how different functional layers interact through a continuous cycle. At the center of the architecture, it lies with the critical cyclical process composed of the traditional four core phase: observe, think, act, and reflect, with together from the engine ongoing adaptation, understanding, and decision making. So to illustrate the architect, we will present, probably Pedro will also talk about that, a real-world application in an environment monitoring ecosystem that involve complex and certain data and require adaptive making. The system integrates sensing, modeling, and reinforced learning and a natural language reporting. This case try to demonstrate how agentic AI and this architect can operate in a practical and high-impact domain. The case study is focused on the Azores lakes. Azores is an island that belongs to Portugal in the middle of Atlantic. It was quite important in that moment because it's where some of the airplanes and the drones of the United States can stop to reinforce the fuel and and other things to go to another part of the world. But this lake faces a risk of degradation and require what we call continuous monitoring. The complexity of the environmental data makes from then, in our opinion, an ideal scenario to applying this architecture. So the system includes sensor agent that collect environment data, analytic agent that model the patterns and classify, in that case, the water quality. So the reinforced learning component that adjusts the intervention, and the LLMs that generate interpretable reports. This complete integration ensures both adaptive and optimization and human-readable communication. Okay? The operation workflow begins with data collection and processing. The system that performs a water quality classification, generate explanation, and evaluate does explanation and update its learning strategy accordingly. This process forms a continuous loop that adapts to new data and environment change. It's a kind of never truly ends and cycle and and reflecting the persistent nature of this system. The reinforced learning in this system alone to Bori?
No,
I'm joking. Reinforced learning along the system to optimize environmental strategy over time. It adjusts the decision to minimize negative ecological impact and improve the predictive accuracy of the system. Through continuous feedback, the system refine intervention and improve outcomes. And the reinforced learning ensure that decision make involve with changing of the environmental condition. The LLM serves as an interpretability layer in the case of study. It explains the decision, translate technical result into accessible language, generate automated report, and facilitate the communication between the system and the human expert. Okay? The system demonstrates improved monitoring capability, more informed decisions, okay? And exchange transparency. Its model and scalable architecture allow adaptation to other domains if necessary. Okay, this is how we, probably it's better this one. Here we introduce the case study architect used to implement the agentic AI framework in the real world. The objective of the, as I say, of this architecture is to demonstrate how multi-agent reinforced learning mechanism language model can be integrated in a cohesive operational system. Okay. The main technology, or the main topic is to implement the architect in the case for agent coordination. This system, in our case, we use AutoGen at the time, which allow multiple agents to communicate. We don't create a new framework. We should not do that, okay? The AutoGen management, the orchestration of the different agents involved in the workflow, but we could even use other framework, okay? Like long chain, etc. For the specialized model optimization, another reinforced learning algorithm has been used that use exploration versus exploitation to balance the search in the hyperparameter tuning of the hyperparameter tuning to extract the most of the model and get the best possible performance of it. I believe that this combination of agent orchestration and reinforced learning enables the system to multiple environments and continuous improvement of the quality of the system. This is some of the agents that we have, that we create. All of them have different tasks and perform different stacks, but they are integrated in the architecture. This is a front end of the interface, which acts as an interaction layer between user and the agentic system. The front end allows user to request analysis. As you forgive me because this is the English version. The front end allows the user to request analysis, visualize the result, and regenerate explanation. All of this was generated by the LLM that we use. It plays a crucial role in transparency and usability because it translates the complex internal operation of multi-agent into accessible output. Okay, so this front end ensures, in that case, that the system remains human-centered, okay, supporting supervision and decision make rather than replacing the expert judgment. Okay, it's all close the loop between autonomous processing and human oversight. Okay, reinforcing a kind of hybrid model that characterizes agentic AI. Okay, so we present a formal integration of models of multi-agent system. I should stop, Pedro. Okay, reinforced learning is supervising me. But I believe this is not a simple combination of technology, okay? It's more than that. I believe that provide a structured model for organizing intelligent and autonomous system. Despite these, there are limitations. We still have problems technical problems that you can, of course, imagine. The previous system of the speaker, you don't talk about that, but you still have probably the same problems. And there are others than in which we still think how to improve the ethical alignment. Is quite complicated in this domain, or the one that present is not. And the accountability is also something that we need to improve, okay? That's my final word. Professor Francisco Herrera already mentioned that from this work, we write a book, a small book, but in which reflect part of our work. It will be accessible very soon, June, okay? We have a lot of work in the fields using this kind of technology. We are involved in the LLM, the Portuguese LLM. In our case, is Amália. Amália was a very, I don't know if you know, more famous person than Cristiano Ronaldo in the last century, because she was a singer, and she sing fado. Fado is the traditional song of my country. It's very hard to explain because you should be human to understand fado. I believe LLM never will understand very well. And in our case, we are developing the case study in education. We are using this architect to develop system that can plan all the class of a professor. You put only what you need, the objective of the learning. We can also integrate part of our books, the books that we use as a kind of reference, and the system with human supervision plan all the class in details, okay? Even if you want the evaluation process, everything, okay? We are now testing the system with human professors that are using the system. It can reduce I don't know if you know, but typically the professor at the beginning of the class should plan all the class. They have two different levels of plan. One is general, it's typically divided in semester or trimester, and they send that to the Minister of Education, in our case in Portugal, because that information the minister wants to know is how you will accomplish the objective of the class, okay? Using the time that you have, 1 year, exactly. And the professor need from that plan, the general plan that is approved in the school, to develop one that class by class, okay? And the plan take typically more than 1 week to do that. In our system, they can do that in 2 hours, just because they lose a lot of time as a human supervision and feedback. Because if he accepts, obviously, it will be very quick. Thank you. So don't forget, the next wave, it will be something different. That will be the wave in which our system will learn to how the world works. That's the main problem, our LLM in the moment. We need to integrate the fundamental law and rules that control our environment, how we do. There are a lot of things that are in imagine most of the, as I think I was with Calvin talking about that, in our ADN, there are a lot of laws and rules that we know from and receive from from the previous generation before us, that help us to manage and to understand the world. I believe this is the things that the system should know. And probably there will be another one that probably the fifth wave that accomplished what we call the AI general intelligence, but it will be another step. Thank you. Pedro. Oh, sure, forgive me.
Okay. Please, can you use? Yeah. But we have the possibility, if you prefer.
We can do that at the end if you don't mind.
And then we have
together.
the question after Pedro.
Can we do that?
Session, okay?
Yeah, sure.
Gracias. Oh, thank you. Thank you, Professor. Pedro, espera, tenho que tirar isto. I believe I should give you that.
Yes.
I forgot. Sorry. Sorry.
Okay, good afternoon, everyone. I think only have 15 minutes around that. No? No? Can go? Can I go? Okay.
Don't worry.
Okay, the first slides.
In the next session later we have the coffee and we have
The group work.
The work of the
Okay, no problem, because the first slides, everyone in the room have heard in the past 2 days what is agentic AI, why agentic AI matters, so I can bring faster in these first slides. Okay, what is agentic AI? Okay, everybody, it's heard in these past few days. We passed the traditional multi-agent systems to a conception of agentic AI that are systems that have agents, capacity of reasoning. Okay, these agentic AI systems represent the transition from reactive chatbots that we have in the 2020 when ChatGPT appears. You are reactive, you put an answer, a question, you give an answer. Okay. The agentic AI, in this case, these agents is just not answer the question, okay? We plan, we communicate, and execute different tasks in different ways, okay? And one question, why agentic AI matters now, in this moment? Can anyone tell me? Opinion, just opinion. Why matters now, at this moment, and not to the key 2028.
It's starting to be applied in many industries and academy. It's like a huge brand new topic that matters a lot because it gives you a lot of possibilities to know brand new things.
Yes, but the answer lies in the scalability and the complex of the systems at the moment, right? For example, our digital process become more complicated. The boom of LLMs, the ChatGPT, turns our systems more complex, and you have a bottleneck, because if you have a human intervention in every single step in this process, you have a little bottleneck here, and the agentic AI allow us to automate the complex and the multi-step workflows that previously required every step the human expert. Okay, in the agentic AI systems, you need human expert. You have, at the moment, human feedback. Maybe next year's not, okay? Maybe in the next years you have LLM as a judge without human expertise to evaluate the answer that this kind of systems gave us.
I agree with you, but it depends on the works that we will do. There are certain works that should be for even the full autonomy, but continues.
Depends.
So you know, we disagree in that.
In Amalia, we try to use the LLM as a judge without human experts. Okay, regarding the agentic AI ecosystems, many of you in the first day, I think, we saw the Creo AI, I think. Yesterday, the Langchain with Ronu. Now, our work focus on Microsoft AutoGen, that now I know it's Microsoft Agent Framework, that migration to in a single framework. And we have also another frameworks like Manus AI. But the point here is all the frameworks all focus on a multi-agent collaboration that are powered by LLMs. The LLMs here serves as an agent brain, okay? But not only the agent brain, because these ecosystems includes much more than that. It includes memory models, allowing agents to remember the past interaction. It's important to remember the past interaction. For example, anybody here work with time series? Okay. We need to remember the past interaction. We have several models that have a memory, a cell memory like LSTM to remember the sequence before. Here you need to remember this past interaction to understand and to evolve to the next level, okay? Here I have a table that comparing the classical multi-agent systems with the agentic AI ecosystems, okay? We have two examples here. The classical multi-agent systems, the example that we have here is SPADE, that is a framework developed by University of Valencia that we use in our classes, and AutoGen by agentic AI. That the next year, the SPADE evolved to agentic AI framework 2 with SPADE LLM that launched 1 month ago, so we'll try to experiment, okay? The classical multi-agent systems in the baseline are a symbolic reasoning. Now with agentic AI, we have the generative reasoning. Everyone works with the traditional multi-agent systems anytime? No? Okay. In the traditional multi-agent systems, we have message protocols well defined, for example, with FIPA-CL. Now, in agentic AI, this message is through natural language chats, like a human. We dialogue with each other and try to evolve in these cases. In traditional math, we need to define for each agent different kind of behaviors. For example, one agent can have 3, 4, 5 behaviors in itself. Here, our behaviors are the prompts and the personas. We need to define the prompts and the personas for each agent. And it's very, very important to have a good prompt for each agent to know what you need to do. Regarding the coordination, in the traditional one, it's via rules. Here, the coordination is via dialogue, okay? The agents look dialogue like the humans, okay? The coordination, okay, these ecosystems normally is cooperative ecosystems, but you can have competition here, okay? But the majority is coordination at the moment. So regarding the AutoGen, just like I said before, it's the framework by Microsoft Research that are created by LLM power agents that are different roles, different goals, and collaborate via natural conversation to achieve a specific goal, or each agent can have a specific goal to a biggest goal to the ecosystem. In this kind of framework, just like a little bit LangChain, okay, but a little bit different, we have two main types of agents in AutoGen. The assistant agent, that are the different types of agents that have the intelligent and powered by an LLM, but sometimes these kind of agents don't need LLM, depends on the context of our problem. And the second agent, the user proxy agents, that are the agent that simulate the human behavior. Okay, you need this agent to simulate or to initialize the conversation, and depends on the context, we need to human input or not, depends. In our case, just to have the input initially, but in the ecosystems through without human feedback. In our example, we use a local LLM, Ollama. I think anyone works with this Ollama, but AutoGen can have the OpenAI, different LLMs. In our case, we use Ollama. In this case, first of all, I will present an example of how to construct and conceive agents in AutoGen, and also we see our agents for the architecture that we saw before in the presentation of Professor Paulo. In this case, we use, in our example, GMAD3 1B parameters. Okay. First of all, we need to configure our LLM. We need the config list. It's a little bit closer to LangChain, just like we saw before. We need to define the model, the OpenAI key, and also the URL. And we can define the temperature of the model. In this case, we are 0.2, but in the other example, we have more temperature. But this config we'll use inside each agent, okay? For example, here we have two different agents, not the agent that simulate the human behavior, because are assistant agents. Okay, the first one is ideator. We tell in the system message that you are a creator. Okay, create, innovate ideas. The second one is an engineering. Okay, you are a technical engineering. Tell me if the idea that the ideator gave us are a good technical idea. Okay, because innovate idea for a technical purpose or a technical point of view, maybe it's not available. It's good to advance to the production, and inside them we put our LLM config that we had before. But if you want, the LLM can be outside the agent. Agent don't have LLM the capacity to reason. Okay, in our case study we will see this case. After that, we define the user proxy agent, the agent that simulates the human behavior. Look, one of the parameters is human input mode. If you put never, you tell the systems, never we will use human input. Sometimes it's necessary, okay? Sometimes it's not, depends on the context, the problem. But also, we put the LLM inside the agent. It's important in this case to use the LLM. But until now, we just define the agent isolated way. But you need to group each other in a way. In this case, we have a group chat. Okay? The group chat, it's important to integrate all the agents of the system. The user proxy needs to be here. Okay? It's not the agents, the assistant agents. No, you need to put together the user proxy and the assistant agent. You can define or not an initial message in the group message. Okay? You can define the max round of interaction of our system. In this case, we put 6. You can go further without problem. And you need to select the speaker selection method. In this case, I put round robin because in this case, we have 4 agents, 4 assistant agents, and the human with the assistant proxy. If I don't put round robin here, maybe one of them do not speak in the system. Because maybe you don't need to speak without them. But this is to control and to put all the agents in the systems once to speak. Okay? After to create the group chat, we need the manager. We need the manager to control the chat between the agents. For this, we conceive the group chat manager and initiate with this and also with LLM config. Okay? And now we need to start the conversation. The agents need a trigger to start this system. So this is by user proxy, because user proxy is the agent that simulates the human behavior. This is this agent that initiates the chat. Okay? But you need to put a message. Okay? In this case, you tell, okay, in this system, propose an innovate idea and evaluate the idea through the different agents present in our system. Pass to our case study that we saw in the previous slide of Professor Paulo. In an example in 2-3 slides ago, we only define a single LLM, right? But you can define different LLMs. Each agent can use different LLMs inside. Okay? In our case, we define 2 different LLMs. Okay? One, a small LLM with 1B parameters, and the other one, a larger, with 27 billions. We'll see why these 2 different LLMs to use. Look, the first thing, put the user proxy, okay, that simulates the human behavior. In our case, again, human input mode, never. Maybe you can tell me. Sometimes you need the input of human. Depends on the context, just like I said before. And also, after that, we need to define, remember the last slides of Professor Paul that we have image collector, preprocessing agent, and so on. You need to define them. Okay. Just look one thing. Here, we don't have LLM, right? This agent don't use the LLM. It's a simple agent at the beginning, and we'll see in the group chat that this agent is not present. Have the prompt, the system message to do the things. Comparing to the traditional mass, if you use the traditional mass, you don't need this system message to tell the agent what need to do. Okay? We put this system message, we'll go through Copernicus API, collect the data, and the job is done for this agent. After that, we have the image preprocessor agent. What are the job for this agent? Okay, receive the image that the other agents collect, and now preprocess this image. Again, look, not LLM config here. It's not needed until the moment, okay? In our context, okay? Maybe we have another agentic AI ecosystems that all the agents present in the systems need to have the LLMs present. And the predictor agents. The predictor agents, the goal of these agents is to load the pre-trained model and classify the water quality, okay? You give us poor quality, good quality, excellent quality, okay? Just a simple word. But for the decision-making process, for the decision makers, this word is not enough. You try to use the LLMs to generate a small text to support the decision, the classification word, okay? And in this case, we use another agent that put LLMs inside. Is the case of the response agent and the test agent. The response agent receives the classification, is poor, excellent, good, and through this classification, give us a small text, a small explanation for the decision makers. But we prepare one thing, it's the small LLM, 1B, okay? So with this, we need to refine or understand this, the answer of the LLM is good or not, because it's a smaller one. So you use a test agent to evaluate the answer of the small LLM, okay? For example, this agent receives the answer of the small one and evaluate, okay? Act like a LLM as a judge and evaluate the answer, give us a rating between 1 and 10, and need to justify why the LLM gave this rate, okay? But just an example. If the answer generated by the smaller one, it's good, for example, with a rate of 7, our bigger LLM need to give us a poor answer to train our model, and we'll see why this is important. Also, in the final, we have a reinforcement learning agent that are responsible to refine our small LLM, okay? The biggest one generate and evaluate the answers. And this reinforcement learning catch the response of the big ones, analyze the justification and the rate. And with this, we'll refine the small one. For this, we use LoRa and gRPU. But before that, look, we need to define our group chat. But if you saw well, the agents inside the group chat, we don't have image collector and preprocessor agent. Just start with the predictor agent. Okay, predictor agents don't have the LLMs inside them, but it's the first agent to initiate all the process of the refining of the model here, okay? In the group chat again, a loudspeaker repair. In the first example, the small example that we saw before, we have round robin like method. Here we define the transition between agents, okay? And the predictor agents can be refined, okay? You can refine our database with different answers to give the small LLM the refine of the process. So, for this we use a reinforcement learning algorithm. Anyone knows GRPO or PPO, just for example? No? Anyone? No? Okay. These algorithms try to have a policy, a reward, or a penalization, okay, in this case. In this case, GRPU are fundamental to refine our small LLM, because the small LLM gave us our indication, our text initially. So we need to refine that to not go to the large one, okay, because it's smaller, it's more faster, computational cost is lower compared to the other. So you need to load the model, the small one, and use this LoRa. Yesterday, you talked about LoRa. In this case, repair, we put the vision layers false, but the other three, language layer, attention models, MLP models, we put it true. Because the first one increased the parameters to fine-tuning. If we're fine-tuning all the parameters, it's evenly close, so we need to understand which parameters that you need to fine-tuning, okay? Also, we format for our GRPO. We have the original prompt, the prompt that the small LM gave us when we received the classification word. We saw if our reject or chosen depends of the reward, because our larger LLM give us the rating between 1 and 10, okay? And this we need to format to GRPO, consume that format, okay? You need the configuration, several steps of our GRPO model, okay, that are returning these training arguments that are used here, okay? After that, we have the prepared GRPU trainer that receive the model, the tokenizer, the dataset, because we construct a dataset with different types of answers to fine-tuning our small LLM, okay? And here, we apply our GRPU reinforcement learning model. We use Unsloth. Anyone knows Unsloth? Someone? Yes? Okay. We use Unsloth for the small one to fine-tuning our small model, okay? Okay, no human feedback? No, but we have some kind of people around us that saw the answers and told us that if the answer is good or not, okay? But repair one thing. Maybe even the large LLM can hallucinate. We don't control the hallucinations here, okay? Every model hallucinates. We can control? Yes. Maybe here we can use RAG, okay, to control the hallucination process. It's a good idea. It's the next step. Okay? We finalize here with the GRPO here, but in the next step we use RAG to control the hallucination of this system. Okay, with this I finalize the presentation. Thank you. O seu?
Não, não tens.
Tenho.
Ok, então deixa eu ver.
Tenho.
Ok.
Tenho este.
Well, first, thank you very, very much for both of you. A very interesting topic. And my question goes, it was originated in the first topic, but then the second even motivated me more for asking the question, because you are talking about reinforcement learning and reflection even in the first talk, but I don't see the reward. Usually in reinforcement learning you have like a reward and a proper metric, and now with agents what's the reward? A prompt to the agent, or how does it work?
In our system, you have two types. I focus on the cognitive system of the architecture. Okay. In this case, are the largest LLM that gave us the rating. The GRPO here is just to refine and to give the small one the opportunity to fine tuning, because it's just like I said in the final presentation. If the largest LLM hallucination, maybe the rating need to be adjusted. But we have another reinforcement learning here, okay, that are in the predict agent, that we use exploration versus exploitation to try to understand and to go to the optimal hyperparameters of our model, of classification model. But here I focus on the cognitive system, don't have the GRPO, but right, our largest LLM gave us the rating. And the GRPO used this number to, okay, I have 7, I need to have another answer with, for example, a rating of 3, for my small LLM can learn, just not learn with the best one, but also with the worst one. Okay, it's important to have the two different of type of answers to the small one learn.
And do you think that you can extrapolate this non-deterministic metric, let's say, into other fields, not only agentic but other fields? If it works here, why not use these non-deterministic metrics in other areas?
Maybe. Okay, depends of the context. For example, in the field of law, I have my doubts.
Okay.
But the question is for our work group. It's the same. It's similarly what we need to do. It's a kind of things that you need to do in our work group.
Let me see that in a different aspect. So, first of all, we want to develop systems, okay? And sometimes, not in the case study that you present, but it could be also in systems that have low resource, okay? Imagine go to the middle of Spain using your mobile, and you want to access to something similar to this. In our group, there are a colleague that is collaborating with an university that have in the north of Portugal specialized in agricultural sector. Imagine to be in the middle of Portugal or Spain using your mobile. You take a photo of the grapes, for example, and based on that, he give you some information to improve the quality of the grapes. Made a lot of things that I do not understand, but this system should be reflexive, because in the set you are using edge computing, etc., and you need the system should be capable of adaptability based on the resource also to create a system in which it could be useful. Okay, that's why the reflexibility also of the system, of the performance of the system, but also about the kind of layers of cognition that Pedro spoke are important, okay? Because you need to be adaptable in the large way, okay? Or dimension.
Okay, thanks a lot.
But we will talk about that.
Yeah.
Okay. I was not convincing sufficiently.
Thank you.
Any other comments? Any question?
Thank you for the presentation. I have a little question for the first presentation. My question is about the LM as explanation layer. How do you ensure that the explanation generated are faithful to the actual decision process and not just a plausible post-hoc narrative?
I do not understand. Forgive me. Can you repeat? Forgive me.
How do you ensure that the explanation?
The definition?
No, explanation.
Explanation, sorry.
Explanation generated for the model are faithful and not is a plausible event.
Probably I was not sufficiently clear about that. Even the explanation and the acceptability of the explanation can be used to the system. When I talk about reflexivity, it means that we analyze the process, but also the reaction of the user, okay? If the explanation was not enough clear, imagine, we can use that information. That's more or less the example of Pedro I've mentioned when we have wrong answers, in that case, not enough clear or sufficient explanation to reinforce the system. Imagine another context. I'm professor. I give you some details about something. You ask me, I understand from your question, you ask me something, and I understand from your question that to you I was not sufficiently clear. I reinforce so the system, that's my goal, should use this kind of information to improve, and it is a continuous loop. It don't mean that in a certain moment I'm completely clear or the answer is enough for you. That's a cycle, okay? That's why I believe the system is very interesting, okay? But we need that information to adapt the system. Okay, of course, that's why Pedro mentioned someone asking in other sector. In real time, we know, namely in healthcare, we cannot do that. But in fact, we do. But imagine that you enter in the hospital. The first step is when they do the triage. Okay, they don't know everything. Then when they give you in Portugal, Manchester triage, a color, it could be wrong. It could be done badly. So it's an improving system, even in that system, okay? So, but of course, if we want to create a kind of autonomous system, but as I mentioned, with human control in the loop, probably we need to reinforce this mechanism of flexibility. But the main goal of our work is to give this input. Our system should also analyze the process and use this kind of features or characteristics of the system to improve the adaptability. It's not enough to have an adaptability based on the action, reaction, or plan, action. No, we need to also go to the details and use that information, okay?
Maybe always, or at the moment, we already need the user information to the...
At the beginning, and it's normal. When you have a tutor, in the beginning, he have a lot of interaction with you, and after a while, imagine Pedro, don't need more anymore. That's more or less a good example. You accept this again? Okay.
Thank you. Thank you. Thank you.
Now it's your turn. Okay. You are a turn.
So I was looking at the front end for the water quality classification, no? Slide 47. Yeah. So it would be possible to add like another agent who is able to understand, give me some information about these that are not in the previous analysis. Okay, so something like, I want to see the time trend of the water quality on the last year,
Okay.
and create a plot that is not in the previous. So when you
For
create
example,
a system,
it's not poor, excellent, good. It's another classification. It's not in the system, in the data set.
yeah, because maybe you created the dashboard, imagining, suggesting something with some idea, no? But I address my personal problems. So maybe I want to create a plot that is not there.
Okay. This here, okay, we have a data set that we collect from Copernicus API, and you need to label the data. We need to use different techniques to label the data, assess the band of the satellites to use, and we have a problem. The data are not balanced. Okay. We need to use techniques like data augmentation for this. And with that, we have the 5 classes that our model can give us, just 5. So in these 5, we try to put in our prompts, okay, we give the classification, and you gave something to this classification, conceive a text to help the decision makers. For example, that in Portugal is the Portuguese Environmental Association, okay, to help these kind of associations, because it's a problem. It's the black box problems. We gave a classification word, a number in the prediction. For us, maybe it's enough to analyze the errors, the metrics of evaluation. But for this type of society, these infrastructures, okay, these people, it's not enough. We need to give a small or a biggest explanation, because maybe it's small, it's not enough for them. So we need to help these systems. It's just not, okay, it's good, it's poor, it's excellent, but why? Okay, excellent, don't help a little bit the people in this type of facilities, but the poor or the medium quality, maybe, okay, it's poor because of this, you can do these things to improve the quality of the water. We try to help the decision makers without this, but all the set, the classification and the text. It's important for these people. The models are not black box, it's not opaque. It's important to this kind of people.
We should be humble. Probably, I don't know exactly in that case, but on what I know. But one thing is, we have system based on data, and based on that data, we can explain something. But we have not enough data. We don't have the data that you need for the explanation that you have. You should be humble, and the system should say, I'm not made for that, simply. Because sometimes we expect that LLMs or this system explain everything. I remember a talk about Professor Francisco Herrera a few months ago, that it was to general public, and he explained what most of the person that use LLMs are using that for understand the relationship between in our society. We ask them, my girlfriend say that, or my wife in my case say that. What should be my behavior or my answer? The LLM was not made to that. Don't do that. You understand my answer too. So be careful. We still are not at the level that we can do everything. Okay? It's my humble opinion. We need to improve our system, and we are doing that, but don't expect that they do everything, okay? That's a problem. We are using this technique in the software company in nowadays, that are the company that provide the software for most of the provider of water in the cities, you know? There are a lot of them in Portugal. What the name?
Multi-municipal wastewater companies.
Providers, okay. And we are working with one of the company that provide the software. And they expect the AI is something that you push a button and give all the explanation, explain all the process. And my answer is, you forgot something. You have the data, but we don't understand the process from the data. We need more information, you know? So that's my humble answer. Depend of the data that we have, and you should be clear about that. We cannot explain what we don't have, the knowledge. And some knowledge is very hard to extract from the data. Oh, I'm sorry, forgot, okay? The process sometimes is not in the data, you know, that how you transform something, and in water process is complicated, because sometimes, you know how they control when they lose water? They don't control. They know they lose water, you know, that, everyone know that. Huh? So the data they provide the city, there are a lot of how do we say that? The fugas? I forgot the name, forgive me. The water we lose, probably, yeah. So, but they control that just because they, you know how? They provide enough water. That's the goal.
And sometimes for the companies, it's theoretical good.
We have time.
Thank
We
you.
need to take the coffee. Thank you very much.
Sorry, guys. Thank you.
Thank you.